Today I am going to start IC engine second part. Next part means that is including Otto cycle, diesel cycle and DI diesel cycle. Okay. So, in previous lecture you have seen the IC engine is having one piston, one cylinder basically, and one crank is here, connecting rod. Okay, so when piston is moving up and down, combustion will be occurring. So, because of combustion, your crank shaft will be rotating. Shaft will be perpendicular to this one. So, shaft is here. Okay, so in shaft you are getting torque. Now, what are the different cycles are there? What two-stroke engine, four-stroke engine? I will discuss. And these topics I have taken basically from Basic and Applied Thermodynamics book and some internet sources, plus you can watch several videos are there available in YouTube. So, just you can Google. I have given 2 links, but there are many videos available, so you can watch. So, before we discuss about Otto cycle, diesel cycle or different types of cycles, we have to know about two-stroke engine, four-stroke engine. Okay, so two-stroke engine, four-stroke engine. So, first you see the PV diagram. In previous day we have discussed one compression cycle will be there, compression stroke, one expansion stroke, arrow direction will be opposite, one combustion will be happening. So, 1, 2, 3, 4. Okay. So, 1 to 2 compression means you have one cylinder, okay, and you have one piston. Piston will be moving forward backward. This is TDC and this is BDC. So, piston will be moving within TDC to BDC, it will not move further there. And you can see this piston, certain specific gap is there, that is called clearance volume. And clearance volume is given for mechanical reason, there is no other specific reason. Okay, when piston is moving towards TDC, you are compressing. So, 1 to 2 is compression stroke. Okay, and this is happening, we are assuming this is adiabatic condition. Okay, so this is isentropic, PV power gamma equals constant, adiabatic or isentropic. Similarly, expansion stroke 3 to 4, that is also PV power gamma equals constant. Now, what is two stroke, what is four stroke? Now, if you see this crank drawing we have done already, crankcase, connecting rod, crank, and this will be rotating like in circular fashion, right. So, this one I said crankcase. Okay, this is your crank is rotating. So, piston will be moving up and down. Now, you can see when crank rotating and piston moving up, let us say initially you filled your cylinder with air and fuel, you are compressing, after certain temperature you are giving spark and fuel will be burning and piston will be moving down continuously, right. So, when piston is moving down because of high pressure gas you created, so you are getting power or torque. Okay. Now, at 4, when you reach at 4 at BDC, piston will be reaching at BDC, this is not BD, BDC. So, there instantaneously you have to remove all the air burnt, whatever burnt gas is there you have to remove. So, but practically it is not possible because crank is rotating continuously, piston moving BDC, bottom dead center, and instantaneously everything will be going out of the cylinder is not possible. So, you need certain time. Again, it will be your combustion or burnt gases will be going out from cylinder. Again, you have to take air and fuel mixture also at the same time. So, how is it possible? So, it is not possible, difficult, right. So, you are getting power stroke, then all gas will be going out of the cylinder and you are getting air and fuel mixture, again you are compressing. So, instantaneously is not possible. Okay. So, if it is happening, so that is why this concept came up, two stroke and four stroke engine. Two stroke engine will have like this 1, 2, 3, 4, but if you have four stroke engine will have like this P, V. So, one is here, as it is I am drawing, 1, 2, 3, 4. Okay. So from 4 to 1, exhaust, we are assuming exhaust happening, but practically it's not possible. So what will happen? Piston BDC TDC. So when piston reached at bottom dead center, you open exhaust port. Okay, exhaust port open, and you push the piston towards TDC. When you are pushing piston towards TDC, you are not taking any air or fuel mixture inside cylinder. So whatever burnt gas is there, you are just removing from the cylinder. Okay, so that means piston be moving again towards TDC. Okay, so this is 1, this is 4, 5, 4, 1, maybe we can say 5, 4 to 5 it will come again. Then again when piston reach TDC, again piston will try to move towards BDC. Okay, because continuous rotation will be occurring. So that time you remove this, you stop or close the exhaust port, open intake port. Intake valve you open and you take air and fuel mixture. So piston moving, you are injecting air and fuel mixture. You fill piston cylinder air and fuel with air and fuel mixture. So that time you are not creating any pressure or you are not taking any pressure. So atmosphere pressure is there. So small low pressure you are creating. So mixture will be entering into the cylinder. Okay. So 5 to 6 again. Okay, 1 and 6 will be superimposed actually, same point. So 5 to 6 actually. So 1 to 5 exhaust gas going out of cylinder. Okay, 1 to 5 when piston moving BDC to DDC, but no power it is producing, neither it is taking too much power. Okay, it is just moving. So just removing burnt gas from cylinder to outside. Okay, so that is called exhaust stroke. Okay, so you are not getting any power. Now 5 to 1, 5 to 1 or 5 to 6, 1 and 6 was the same point actually. So 5 to 1, remove, stop or close the exhaust port, open intake port, you take air and fuel mixture. Okay, so 5 to 6 or 1, taking air plus fuel. Okay, now what happened? BDC after power stroke, remove all the gas, burnt gas, there is no fuel available because already combustion happened. Again move towards BDC, take fresh air and oxygen, fresh air plus fuel. Now close both valves, exhaust and intake, start compressing. When you are compressing, temperature will be increasing, volume reduced, pressure increased, temperature increased. Okay, after a certain time it will be burning instantaneously. Okay, when burning happening, so here again we are assuming at point 2 combustion is happening instantaneously. Okay, so 2 to 3 combustion happening, but 2 to 3 you see this volume is 0, sorry, volume is constant. So in practically it does not happen, volume will be constant. So practical cycle will be like this. If I draw practical cycle, okay, there will be no sharp corner, but for our calculation purpose we are giving some sharp corner so that you can calculate and you can see what is happening. Okay, so 2 to 3 combustion happening, that means you are getting lots of heat. Okay, then 3 to 4 exhaust, 3 to 4 power stroke, is called power stroke. Okay, now you can see this 4 stroke engine, this is 4 stroke, this is 2 stroke. Okay, so in 2 stroke what is happening? Crank rotating 360 degree and one time compression, one time expansion happening. Okay, but you see 4 stroke engine actually 720 degree rotation will be happening, then one compression, one power stroke you are getting. Okay, so crank rotating 720 degree, here crank, okay, you can see when piston moving up to down 180, down to up 180 for 2 stroke engine. For 4 stroke engine up to down 90 degree, then exhaust, intake, so 90 90, again compression, so 90 90 90 90, oh sorry, 180 180, 180 expansion or power stroke, then exhaust 180, intake 180, compression 180, so 180 into 4, okay, 70 degree. So 2 stroke 4 stroke is that 2 stroke will take only 360 rotation of crank, but 4 stroke is taking 70 degree. Then what is the difference? Why should I use 2 stroke or 4 stroke engine? Now 2 stroke engine, you can see when air is exiting near 4, we are not giving enough time for the air, okay. Again intake also will happen at 1, so there is possibility of mixing of exhaust gas and intake fluid, intake fuel air mixture. So what is happening? So intake fuel air mixture you are giving, but exhaust gas also same port will be open at the same time, so your energy loss will be there, complete combustion may not be possible, okay. So it may not be good for your environment. So in India also, India government instructed to remove 2 stroke engines actually, okay. Chennai Autos also government instructed to remove 2 stroke engine, use 4 stroke engine, because 4 stroke engine is having separate intake stroke, exhaust stroke. So inlet fuel air mixture and exhaust gas, burnt gas will not be mixing, okay. So then complete combustion possible, no fuel loss, no environmental hazard, okay. But 2 stroke engine, it will have mix up possible mixing of exhaust gas and fuel, so environmental issue will be there, your fuel economy will lower, fine. So propeller speed for 2 stroke cycle 80 to 100 rpm propeller speed will be there, for 4 stroke cycle 250 to 750 rpm, okay. So it is around 200 rpm propeller speed will be there, but IC engine speed normally it will be higher, okay. Then you have to use gearing mechanism, later we will discuss about gearing mechanism, clutch mechanism, other mechanisms, okay. Okay, formula I will discuss later. So what is the next? Flywheel, okay. Flywheel, just wait. Okay, I think I took this picture from your sarang, you may have remembered, okay. So this is IC engine actually, whatever IC engine I am teaching. So IC engineering will have crankcase will be here inside, there will be crankcase will have lots of lubricating oil, okay. And engine is hot gas engine, so it must be cooled, so that's why there is having one fan, the fan will be reducing engine temperature, okay. And there is one flywheel, this heavy mass is there, okay. This is called flywheel. So what is flywheel? Flywheel conserves angular momentum. See, let's say shaft is rotating, and if I have heavy mass, so this heavy mass will absorb energy, okay. Now because my engine, when it is rotating 360 degree or 720 degree, I am getting one time power. Let's say 4 stroke engine, you can remember, one time moving backward, forward, compression, expansion, so many time moved, but you are getting power only one time, okay. So then how the smooth power you will get for your specific application, maybe your car, bike, truck, train, anywhere. So you need continuous smooth power, right? So your car should not move like move then stop then move, it will not do like this. So you need a smooth power, the smooth riding experience. So smooth power supply is required for electrical production, for any moving vehicle, shipping applications, okay. So for that actually you should have flywheel. So flywheel, what will you do? They say during idle stroke, piston should be moving forward backward, you need certain amount of energy, so the flywheel will be storing energy, heavy mass, when you are rotating, it will be absorbing energy, and during idle stroke and compressor stroke, it will be supplying energy. When you are getting power stroke will have pressure pulses. I can draw one timing diagram, turning moment diagram, okay. Turning moment diagram is like this, Suction will be like this, then compression, then power stroke, then again like this. So this is this will be about suction stroke. Suction stroke means 1 2 3 4 5. So 5 6 5 6, you can say 5 to 6 suction stroke, and then you are having compression stroke. Compression stroke means 1 to 2. Okay, then you have working pulse, that is power stroke, 3 to 4, and 4 to 1 or 1 to 5, 1 to 5 exhaust. This is power stroke. Okay, so you can see your crank rotated 720 degree or maybe 360 degree, but you are getting one time power and very high pressure or high power. Okay, so that power may not be useful for your car application, motorcycle, anywhere, right? So you have to smooth it. So if I get a turning moment like this, it will be very good. Okay, but practically it's not possible. So engineers or scientists thought, let's put some flywheel. So flywheel will be smoothing the power. Okay, it will be storing energy during peak high power stroke. It will be absorbing energy, then other strokes it will be supplying energy. Okay, and how much smoothing you need, based on that your flywheel size will be decided. If you make very smooth power, then your flywheel size will be very high, very large size flywheel you should fix there. But if you think some pulsation is okay, then a small flywheel will be okay. Okay, so flywheel used to smooth energy fluctuations and make the energy for intermittent operating machine more uniform. Flywheels are used most combustion piston engines or CI or IC engines. Okay, so kinetic energy is stored, kinetic energy stored half I omega square. I think it is coming from your +2 books, right? So half into I means moment of inertia, omega means rotational speed. So what is I? I will be coming as k m r square. What is r? R means radius, radius of the flywheel. So flywheel will be like circular in shape. Okay, central hole may be there. K is inertial constant. K inertial constant depending on the shape of the flywheel. M is the mass of the flywheel. R is the radius. Okay, so K value, K will be 1 for rim like cycle tire tube, that assembly. Okay, so the value will be 1 for cycle rim type, rim like bicycle tire or rim. Okay, its value will be 0.606 for solid disc with uniform thickness, 0.3 for flat disc with central hole. Okay, so if I know the K value, M value, I value, I can get kinetic energy, how much energy it is storing. Then if we make average it, then you can say, okay, this much of size may be required for smoothing the power. Okay, just wait. What is this one? Multi-cylinder engine. Okay, multiple cylinder engine. So you may have seen the V type engine, other type engine. Maybe it is used in many cars, and even high end motorcycles also they are using V type engine. Very heavy vehicles like cargo ships or your marine machinery, heavy machinery, especially trucks, they'll be using V type engine or multi-cylinder engine. So one cylinder you are getting pulse like this, right? One time pulse, no pulse, like this. Now multiple cylinder will reduce these peaks and it will make more smooth power. How does it look like? Like say if I have cylinder 1 here, another cylinder here, it is connected to common crank, so it is rotating. So what will happen, you see one piston is going up while other piston may be going down. Okay, I may have many other pistons also. Okay, so for example, I may have piston here also. If I have many piston, then I will have many pulses, right? 10, 20, many I can make, right? So actually you see average pulse almost smooth. Okay, that's why they'll have multiple cylinder engine and different arrangement also there. For example, one arrangement, this is V. If I have like this is V engine. Okay, it is looking like a V shaped. Opposed cylinder piston will be there, engine. Opposed cylinder engine will be like this. Crank shaft is coming, crank is there, crank is here. Okay, these are my bearings, that's why I am writing like this. This is my shaft, crank shaft. Okay, this is called crank shaft, and this is crank. So crank is connected to connecting rod, then my piston is here. Okay, this is my piston. I am just making shaded. Okay, there also another piston. Okay, this is piston, this is connecting rod. Now you see, if I rotate the shaft, piston, one piston will be moving towards TDC, another will be moving towards BDC. So I am getting like two pulses actually. Instead of one pulse, I am getting now another pulse also. Okay, so little bit smoothed. Now if I want to smooth further, then I can make piston arrangement like this. Okay, piston one here, another piston maybe here, another piston maybe here. Okay, and I will have bearing every time, everywhere there will be bearing, other will not rotate. Okay, these are bearings. Okay, so this is inline piston arrangement. ARRANG. Okay, some other will be like radial piston arrangement. Radial piston arrangement will be like this. One piston may be here, another piston may be here, another will be here, another will be here. Okay, so connected this one will be connected, this will be connected, this will be connected, this will be connected. Okay, so one common crank and different connecting rod, and piston will be rotating, I mean moving forward backward, but in sequence. So you are smoothing the power actually. So flywheel is working, but for smaller application like for your like sarang application, small engine, flywheel is okay. But when you need big power for cargo ship moving, a train, a truck, so in that case you need multiple cylinders. So that will be smoothing the power and your flywheel requirement will be lower. So flywheel means heavy mass you are carrying unnecessarily, right? Heavy machine truck is there. So instead of carrying the heavy mass, you make multiple cylinder, you get total power higher. Okay. Okay, this is done. What is the next topic? Terminology. Okay, so different terminology will be using when we will be solving problems for IC engines. Okay, you have seen PV diagram. 1, 2, 3, 4. I am not showing idle stroke every time because idle stroke is not contributing in power, or it is not taking power also, we are assuming. Although there will be certain friction and other losses, but we are approximating, so we are assuming there is no power loss or no gain from this idle stroke. So that's why maximum time I do not show actually. Okay. So this is compression stroke, you know, compression. This is expansion stroke. this is combustion, okay, and this is exhaust. This is exhaust. Okay. Now, if I have many types of cycle, this is called Otto cycle. Okay. This is not like Chennai Otto. This is OTTO. Okay. Another cycle is like this. This is called diesel cycle. There are many other type cycles are there, but basically two cycles are very common. Otto cycle basically for 2-stroke engine, diesel cycle will be basically for 4-stroke engines. 4-stroke engines already I said like 720-degree crank rotation, 1 power stroke, but complete combustion is possible. It is good for environment and it is good for your economy also. Okay, so 1, 2, 3, 4. So you see the change in Otto cycle, in diesel cycle, 2, 3 you become horizontal. Okay. So diesel cycle 2 to 3, this is constant pressure process. Okay. So compression ratio, these terms you have to remember. Compression ratio equals V1 by V2. V max by V min, V max by V min. Okay, cutoff ratio. Cutoff ratio for diesel cycle actually, for this one. Diesel cycle cutoff ratio V3 equals by V2. Okay, a pressure ratio. V P1 by P2. Okay. So whenever you are solving problem, these terms will be coming, so you should remember. Okay, clearance, swept volume. Swept volume is V1 minus V2. So piston is moving 1 to 2, so the swept volume will be V1 minus V2. Okay. Mean, okay, you are writing. Some more terms will be coming, later discuss. Okay, I'm changing slide. Carnot cycle, so effective pressure. Okay, mean effective pressure. It is used in thermodynamics and engine performance analysis to represent the average pressure throughout the entire power. So you can see pressure and volume diagram, whatever I have drawn. So it is pressure is changing actually, but if I make like this, if I take this one, if I assume this average pressure is here, okay, this is P max, P min may be 0. Okay, so average pressure throughout the entire power combustion stroke is same, and it simplifies the analysis of engine performance by providing a single pressure value that, if acting over the entire stroke, would produce the same amount of work as the actual pressure variation during the engine cycle. So, it is the formula for this one. So, W net output power MEP V max, this is V max, this is V min, okay, minus V min, MIN. Okay, so minimum MEP equals W net divided by V max minus V min. Okay, this formula will be using later. So Otto cycle will have, I already told, P, V, and you're compressing completely, then combustion happening, then expansion happening, then exhaust happening. Okay. So already you are familiar with these terms. Intake stroke, here intake stroke is not there, no separate intake stroke, but if you want to represent, then you have to draw like this. Okay. Basically this is spark ignition engine, and you know, spark in bike, there will be these days battery operated bikes are there, right? Car also, if just rotate the key, it will be starting. So there will be battery, so battery will be creating small spark. Okay, you compress it, then you give small spark. So I got one spark plug, actually I can show you how does it work. So if you put positive uh, electrode here and negative here, so because of small gap and if apply very high voltage, because of that, in small spark will be created. Spark means very high amount of energy it will be releasing. So because of high amount of energy it is releasing, and combustible fuel and air mixture is nearby, so that some particle will be burnt. So some particle will be burning, they will be producing again exothermic reaction, I mean lots of heat will be producing. So that heat will be transmitted to another particles. So in that way, the whole cylinder, inside cylinder, whatever fuel is there, fuel and air mixture, it will be burnt. Okay. So this is one spark plug. I think it is bike spark plug I got, so I brought, maybe you can see later. Okay, this is called indicator diagram also. Okay. So we will try to formulate some equation, efficiency equation, how to calculate pressure, temperature, different points based on your simple Boyle's law, Charles law equations. Okay. So this is PV diagram, and TS diagram will be like this: 1, 2, 3, 4, TS. Okay. Let's aim in the mass flow rate. Mass flow rate. Q1 is heat addition. Okay. Q1 equals Q2 to 3 mCV T3 minus T2. Okay. Simple formula. Q2 heat rejection 4 to 1, Q4 to 1 equals mCV, again constant volume process, so mCV T4 minus T1. Okay. So what is eta? Eta will be 1 minus Q2 heat rejection divided by heat intake. Okay. So 1 minus mCV T3 minus T2 mCV T4 minus T1. Okay. Now mCV will be vanishing, the same value, equals 1 minus T1 by T2 T3 minus, wait, some mistake is done, T4 minus T1, some mistake happened. Q, what mistake? What mistake? Okay, this one, right? Q2. Okay, Q2 T4 minus T1 and mCV T3 minus T2. Okay. Now T1 by T2, so T4 by T1 minus 1, T3 by T2 minus 1. Okay. Now T2 by T1, T2 by T1 equals V2 by V1 gamma minus 1, gamma is specific heat ratio. Normally if I do not give any value for your exam purpose, so you take 1.4. Okay. So T3 by T4 equals V4 by V3 gamma minus 1, and V1 equals V4, V3 equals V2. So then we are getting T2 by T1 equals T3 by T4, or T1 by T2 equals T4 by T3. Okay. Or T4 by T1 equals T3 by T2. Okay. So if we replace all these values, so 1 minus T1 by T2 equals 1 minus 1 by R gamma minus 1. R equals compression ratio V1 by V2. Diesel cycle, we discussed that PV and your heat addition process horizontal, means constant pressure process. Okay, 1, 2, 3, 4. And whenever you are drawing, please put proper arrow direction also. Okay, if you put wrong arrow direction, then meaning will be different. So in that case, you may not get marks. PV per gamma equals constant. This one also PV per gamma equals constant. Okay, TS diagram also will be same as Otto cycle 1, 2, 3, 4. Okay, so here Q1 heat addition process and heat rejection process here Q2. So we are approximating heat, we are assuming that heat is getting rejected at 4 to 1, but in actual process there will be separate stroke. Exhaust gas will take all the heat actually. Okay, when you are removing exhaust gas, that exhaust gas, heated gas, that will be the heat rejection process, but here because of approximation we are assuming 4 to 1 heat rejection is happening. Okay, so eta equals 1 minus Q2 by Q1. This is the formula, heat rejection divided by heat addition. So 1 minus mCV T4 minus T1 mCP, you can see here Q2 by Q1. Okay, Q1 is CP actually, constant pressure process. Okay, but heat exhaust is constant volume process. T3 minus T2. Now we'll be solving this one. We'll try to formulate the efficiency equation. T4 minus T1 gamma T3 minus T2. Okay, so compression ratio R equals V1 by V2 equals specific volume, I can write V1 V2. So many times we specify specific volume per kg, then small v we write. But now if we have mass value also, then we can write capital V. So that is normally people will be assuming this is the notation. Okay, expansion ratio. Okay, here another term we were getting, RE equals V4 by V3. I can write this one RK. V4 by V3 equals V4 by expansion ratio V4 by V3. Okay, so it is not, no need to write. Cutoff ratio. Cutoff ratio RC equals V3 by V2 equals V4 by V3. Okay, specific term it is written V2. So RK equals V1 by V2 equals V4 by V2 equals V4 by V3, V3 by V2 equals RE RC. Okay, RK is related to like this, RK equals V RC RE. So now process 3 to 4. 3 to 4 process means it is expansion process. So T4 by T3, T4 by T3 equals V3 by V4, V3 by V4 gamma minus 1 equals 1 by RE gamma minus 1. Therefore, T4 equals T3 RC gamma minus 1 RK gamma minus 1. Now 2 to 3. Process 2 to 3 is heat addition process, constant pressure and heat addition, right? So T2 by T3 equals P2 V2 P3 V3 equals V2 V3 equals 1 by RC. So T2 equals T3 divided by RC, and 1 to 2 process T1 by T2 equals V2 by V1 gamma minus 1 equals 1 by r k gamma minus 1. Okay, so substituting eta equals 1 minus T3 RC gamma minus 1 RK gamma minus 1 T3 R3 T3 by RC, I think RC 1 by RK gamma minus 1 divided by gamma T3 minus T3 1 by RC. So this is giving 1 minus 1 by gamma 1 by RK gamma minus 1 RC gamma minus 1 RC minus 1. Okay, as RC greater than 1 implies 1 by gamma RC gamma minus 1 RC minus 1 greater than 1. So eta diesel less than eta Otto. Same compression ratio. Okay. Okay, thank you very much. And next we will start the calculation part. Thank you.